This video has two samples, two means of men and women. So this is going to be a two-sample test. We're trying to compare these two groups to each other. And then another thing you need to know here is that you need to know whether you use Z or T based on one thing. You use Z when you have the population standard deviation, right, which is sigma. If they say sigma is equal to blah blah blah, you are doing a Z test. If you do not have population standard deviation, or there's no real mention of it, then you use a T test. Now they do mention population standard deviation, those words pop up right here, but they tell us to do not assume that they are equal. So let me explain that. So there's two different ways to do the T test. Now there's two different ways here, so let me get the formula sheet and I'll show you the formulas which will help understand this. So straight off the formula sheet, you see if you have, of course if it's a proportion, these are not proportions, but if it were, those are a Z test, and it's proportion on the calculator. Down here Z is two means are independent and sigma is known. Standard population standard deviation is known of both men and women body temperatures. We don't know that. What they did tell us is do not assume they are equal. Alright, so this formula is going to apply because it says there's two means. Sigma 1 and sigma 2 are not known. We don't know them, and they are not assumed to be equal. So in a formula sense, this is what we will use. This one is when you assume that the population standard deviations are equal. It's a similar formula, but you use pooled standard deviation. This one is not pooled, and that's important to understand, pooled standard deviation. So this means pooled, and this is not pooled. So let's look at the calculator to make some sense of this. So in the calculator, we're going to go to Stat, and we'll go over to Tests, and we're going to go all the way down to a two-sample T test. Let's see, I skipped this. Option number 4, two-sample T test. And I'm going to type in my data here. Let me type that in. Alright, so I've typed in those values for the men first and the women second. It doesn't really matter which order. Now our hypothesis test here, according to answer choice D, said we're going to try to prove that men have a higher body temperature than women. So we're going to do greater than. And then we'll go down and we'll say pooled. We're going to say no, and that's because we do not assume the population standard deviations are equal. So again, that's what we meant by pooled earlier. The second formula used pooled, and this one does not. And so that's where we get our T is 1.72 as shown here, and our p-value is 0.56. When you round that, you get 0.56. And then our hypothesis, our conclusion for our test is we would fail to reject the null hypothesis because there's not sufficient evidence to support the claim. And again, that's testing against a significance level of 0.1. So remember, what we mean here is that this number here needs to be less than 0.01, and it's not, and that's why we choose fail to reject, and there is not sufficient evidence. Alright, so now on to part B. Let's talk about part B, and I'll get the calculator back out. Alright, so now I'm going to get out of that calculation and quit. Alright, so we'll do Stat, and we'll go over to Test, and now we're going to go down to option 0, which is a two-sample T interval. Alright, now if you notice, it's kept our data. Thankfully, we don't have to re-enter that data. Now the confidence level, this is what's going to be important. The pooled is still no. The only thing we have to adjust here is this confidence level, so let me explain that. If you have a 0.101 significance level, when you're doing a one-tailed test, what we were trying to prove was, on a standard normal curve, that right here was 1% of the data. Now when you do a confidence interval, what you do, a confidence interval is balanced about the mean. So in this case, what we need to do is we have our 1% here, and then we also give another 1% over to here. And it basically says that we want to be sure up to 99%, really 98% here, that the mean will fall somewhere within these two. And so we'll change that to a 0.98, because if we have 1% here, that means we have 98% on the interval. And so I'll go back and do calculate, and we get 0.292 and 1.322. And then the answer to the last question, it does support the conclusion because the confidence interval contains 0, meaning that there's possible that the difference in the means is nothing.